This video is part of a free course. If you want to learn more about working with FANUC robots in an easy-to-follow format, head on over to realpars.com, where you can sign up for this course, as well as several other courses on PLC programming and other topics related to industrial automation and robotics for free. You can find the link in the video description as well. In this video, I will explain what 6-axis simulation software is, what it is used for, and the advantages and disadvantages of using it. Programming 6-axis robots is typically a hands-on process, using a teaching device that is usually in sight of the 6-axis robot. Sometimes you don't have access to a 6-axis robot, and you still need to design, program, or troubleshoot a 6-axis robot. Some robot manufacturers have software to simulate running a 6-axis robot to help with the design. 6-axis robot simulation tools are usually hosted on a computer that simulates a real robot. The interface, which is called a graphical user interface or GUI, typically uses a combination of clicks, mouse movements, and key presses. Some 6-axis simulation software will even replicate or copy actual files from the real robot. 6-axis robot simulation software makes a virtual representation of the physical robot. The GUI software can be in 2, 3, or 4 dimensions, depending on the manufacturer. The environment that is created using the GUI will help you visualize the 6-axis robotic cell. The ability to see the robot in its virtual environment can be helpful to robot designers, programmers, and engineers. 6-axis robot simulation software can be used for many purposes. One of the many things 6-axis robot simulation software can be used for is specification purposes. The software helps you pick which robot is right for the job. Using the simulation software, you can select a robot virtually and see if it will fit and maneuver well with any equipment, tools, or obstacles that are part of the job. When selecting a robot, sometimes you have control of where the robot can be placed, and sometimes you do not. When you get to choose where the robot will be placed in the cell, you can select a location that is away from obstacles. Generally, obstacles should be avoided because they can cause a 6-axis robot to slow down or even hit obstacles when accidental programming mistakes happen. When obstacles cannot be avoided, 6-axis simulation software can help lay out the obstacles and program around them. For example, you're designing a robot cell with a robot with 2 pick locations and 2 place locations. In between the place locations, there's an obstacle, which is an I-beam. If the 6-axis robot makes a direct path while going from pick location 1 to place location 2, it will hit the I-beam. As a robot programmer, you can pre-program a sequence so that the robot regresses from pick location 1 to a path in which the 6-axis robot will not hit the beam as it tries to go to place location 2. Because you simulated the robot cell using a virtual robot, you were able to anticipate the I-beam and program accordingly. Designing robot cells using simulation software can also help you choose which 6-axis robot to use. The distance the robot needs to reach is a design consideration when selecting a 6-axis robot, so that it is the correct size for the job. Another design consideration is how fast the robot needs to go. After you design the robot cell and program the robot flight path, you should time how fast the robot performs one complete cycle. Some simulation software has an option to let you time the cycle and then record the cycle time. While timing the cycle is important, it is also important to budget for some safety factors. For good measure, it is wise to use the 5/6 rule. This means you should meet cycle time with the robot able to go an extra 1/6 speed. Using the 5/6 rule will help you design the robot to meet cycle time or determine that the selected robot will not work. Either will let you decide what robot to use without purchasing multiple robots, which purchases can incur significant costs. Some simulation software allows you to import different types of CAD files to interact with your robot cell. This can be useful because you can import files that recreate the machines that will have to interact with the 6-axis robot, rather than creating that programming yourself. This can be especially helpful when interacting with many complicated machines. I will now describe the advantages of using simulation software for a 6-axis robot. 6-axis simulation software can help you visualize the robot cell when designing or troubleshooting 6-axis robots. As described earlier, testing and simulating a robotic cell can add value to the design process without having to buy a physical robot to test on. Simulation software can also be helpful to reproduce a problem that would be inconvenient or impossible to reproduce on the actual robot. Reproducing a customer's problems using simulation software can help you find a resolution to the problem when you are not able to physically be at the robot. Also, simulation software is far less expensive than buying a robot, so there is somewhat more margin for trial and error. Simulation software can also help when you do not have a robot to work on and you still need to program the project. A word of caution: simulation software can be helpful, but can cause false assumptions if you are not careful. For example, if you do not pay attention to every dimension and place your cell into an area which is smaller than you have anticipated, it could cause the robot to knuckle up and go slower than your simulation predicted. Sometimes simulations for 6-axis robots can take too much time, especially to put every little detail into it. You need to be wary of how much time you spend making your virtual cell in 6-axis simulation software in order to be sure you are using your time efficiently. Sometimes it is not cost-effective to create a simple cell using simulation software. There is a delicate balance between how much time to spend simulating a 6-axis robot that you will have to learn after some practice using the software. Simulation software can be an extremely helpful tool when designing or troubleshooting a robot. It will help save the costs associated with a physical robot. Simulating a robot will also help you learn how fast the robot can go and what its physical limitations are. Simulation software is a helpful tool for robot programmers. Simulation software will ultimately help you make decisions that could save you much time and effort during the design and troubleshooting process. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.